Gravity flow systems are pipe configurations which are constructed for the purpose of moving liquids and solids underground. Installed on a slight slope called a gradient, the only propelling force is gravity. Examples of gravity flow systems include sanitary sewer, storm drain, and subdrain. The style of pipe utilized in each system depends on various factors such as local plumbing codes, state codes, depth of bury, soil type, and engineering designs. A mainline sanitary sewer routes wastewater from a community to a treatment facility to be processed before its release back into the environment. Sanitary sewer pipes are commonly installed with a small amount of gradient. If the slope is too great, the liquids tend to separate from the solids and create blockages. Direction changes for sewer pipes can also cause blockages. To prevent this, manholes are always installed where a change of direction or grade is needed. They are installed 200 to 400 feet apart to allow easy access for cleaning, maintenance, and inspection. Common types of pipe installed from mainline sanitary sewer systems are ductile iron, polyvinyl chloride, and clay. Ductile iron is usually used when the excavation is abnormally deep or when the installation requires a strong pipe that can withstand heavy surface pressure. Polyvinyl chloride pipe, or PVC, has many characteristics that make it a preferred pipe for sanitary sewer installations. PVC is lightweight, has strength, rigidity, and a smooth interior. Clay pipe, although exhibiting considerable strength, is a brittle material that breaks easily and needs extra care during installation and backfilling. Since sanitary sewer systems carry liquids and solids, accuracy requirements are more stringent than for other utility installations. Accuracy requirements of 1/100th to 300th of a foot per length of pipe are not uncommon. Since direction changes only occur at a manhole, a laser is one of the most efficient ways to control line and grade. Always refer to the local plumbing codes to determine the actual requirements in the area of installation. In installations where limited work area or unstable soil can create a cave-in hazard, a protection system for workers is mandated by OSHA. Contractors usually select a trench box because they are easy to install, can be moved easily as the pipe laying progresses, and are effective worker protection systems. Installation procedures are determined by the type of pipe. A standard procedure for installing PVC pipe is the bell and spigot method. A normal bell and spigot installation consists of these basic steps. The tailman digs a bell hole and cleans both bell and spigot ends of the pipe. He checks that the gasket is in place, then lubricates the bell, spigot, and gasket. The lead man fine grades the ditch bottom using a marked shovel and laser beam as a guide. He checks the ditch bottom every couple of feet to ensure a consistent slope. When lifting a section of pipe, the choker must be centered so the pipe hangs level. The top man guides the pipe into the excavation until the lead man takes over control. Carefully place the spigot into the bell, making sure no dirt or debris is present, and that the section being installed is in alignment with the previous pipe. Use a wooden block and pry bar to push the pipe until fully seated. A black line on the pipe can serve as a gauge indicating when the pipe is fully inserted. Place the laser target inside the pipe behind the bell. Level the target until it sits at the center of the flow line and adjust the pipe to the laser beam. A pipe maintenance feature often found in a mainline installation is called a cleanout. A cleanout is placed at the end of a line, such as in a cul-de-sac or dead-end street. A cleanout rises from the end of the main line to the surface at approximately a 45-degree angle. This allows easy access of cleaning tools, such as a snake or flush hose. A private residence usually has a smaller diameter service pipe, approximately 4 inches around, called a lateral, leading out to the sanitary main. The service pipe is attached to the main using a saddle that is either strapped with stainless steel clamps or is glued to the main. Sewer saddles are sometimes specified by the plumbing code to be set at different clock positions on the main line. Check the local code and project specifications for the proper clock position for all service installations. To install the saddle, mark the diameter and location using the inside of the gasket or the saddle as a template. Mark the cut line approximately 1/4 to 3/8 of an inch larger than the diameter of the saddle. After cutting the hole, attach the gasket to the saddle and mount to the main line by either gluing or tightening the clamps to achieve a sealed and secure fitting. When installing a service, always check the pipe to ensure the slope is away from the building and toward the main. A common rule of thumb is to slope a service lateral at a 1/4 bubble on a 4-foot level. To ensure each joint of pipe is laid at a consistent slope, secure a block of wood 1/4 to 3/8 of an inch thick to one side of the level. Install the pipe with the bubble reading level. In any gravity flow installation, the longer the slope, the deeper the excavation. Also, the excavation will deepen rapidly if the surface slopes in the opposite direction from the design slope of the pipe. When the excavation gets too deep, a lift station is used to raise materials from one elevation to another. A lift station can also be used to lower materials if the natural ground slopes too steep to allow for gravity flow. In some circumstances, a contractor or project owner may be required to have an independent agent perform a test on a completed sanitary sewer installation. Most testing specifications require a pressure test. A low-pressure test is performed on an isolated section of pipe. This test requires an air compressor, hose, wood bracing, test plugs, and a hand pump. Pre-test flushing of the line removes debris and can improve the overall test results. To begin the test, place a plug in each end of the line and tighten securely. Brace the plugs at the ends of the pipe. Attach a whip check cable to the plug end. Then connect the airline hose. Once connected, slide the cable loop over the end of the hose. The whip check is a safety measure in case the airline should break. The whip check prevents the pressurized hose from whipping out of control and causing injuries. Attach tie wires to the connections. This second safety measure prevents the fittings from coming apart. Under no circumstance should anyone be in or near the manhole during the test. As little as 5 pounds of pressure can create 250 pounds of force on an 8-inch plug. Slowly open the air control valve and regulate the air flow to gradually increase the pressure inside the line. A sudden increase in the air pressure can blow the pipe or plugs apart. A common practice is to pressurize the line a 1/2 pound per square inch higher than what the testing specifications require. This allows the pressure in the line and the gauge to stabilize. To regulate the pressure in the line, Periodically open and close the air regulator valve. At the same time, monitor the gauge reading until the required air pressure is obtained. The amount of time for the pressure to build up varies depending on the length and diameter of the pipe. In order for the line to pass the test, it must maintain the minimum allowable pressure during the testing period. When the test is completed, the air regulator valve is opened and the pressure is released. Never enter the manhole or remove the plug until the air pressure is released completely. Repair methods will vary depending on the type of pipe. There are several types of couplers designed for specific pipes. Most repairs employ couplers that clamp both ends of a replacement pipe section to the original pipe. Dresser couplings may be used on ductile iron, PVC, or pressure lines. To begin repair with a dresser coupling, remove the damaged section. Dig a bell hole that's deep enough to allow clearance and access to the coupler. Measure the overall width of the coupler and clean both ends of the pipe. Mark the ends of the existing pipe 1/2 the coupler's width. Next, clean the replacement pipe and place the couplers over the ends. Lower and position this piece in line with the existing pipe. Slide the couplers up to the positioning mark. Then, tighten the bolts. The proper tightening sequence requires starting with opposite bolts and then proceeding in a rotational order. Start with any bolt and tighten a couple of turns. Then, tighten the opposite bolt. Make sure the bolts draw the coupler in evenly and compress the gasket. After completing a few rounds, finish tightening to the final torque using the rotational sequence. Start with a bolt and turn a few times. Move to the next bolt and repeat. To achieve proper torque, repeat the rotational sequence 2 to 3 complete revolutions until all bolts are evenly tight. Wraparound couplings are used on ductile iron, PVC, and cast iron pipe. Thoroughly clean the area to be repaired. Measure the coupler and mark the pipe for correct positioning. Open the wraparound, slide around the pipe, and position at the mark. This will center the coupler over the repair. Tighten the bolts evenly to the final torque. Flexible rubber couplings such as Mission and Fernco are used mainly on vitrified clay, PVC, cast iron, and ductile iron. Follow previously described procedures to prep the pipe and coupler for repair. After installing the coupler and centering on the repair, tighten the stainless steel clamps. Because this type of coupler is extremely flexible, pay close attention to alignment during initial backfilling. A standard practice for any repair is to run water through the repaired section to check for a secure seal. The repair methods for dresser, wraparound, and flexible rubber couplings are not limited to the types of pipe shown and may be used in other applications. Storm sewer systems are designed for the control and movement of ground, surface, and rainwater. These systems collect water from parking lots, roadways, or any area where standing water might cause flooding. This excess water is moved to a natural drainage area for a controlled release back into the environment. Storm sewer installations are made using lead pipes that connect inlets and catch basins to the main line. Catch basins collect and direct surface water. Grate tops or drop inlets allow the water into the basin, and an outlet pipe directs it to a main line that dumps the water into a river, pond, or drainage area. Catch basins also make it possible for maintenance crews to access the storm sewer line to perform cleaning, flushing, repairs, or inspections. Maintenance crews have to clean catch basins on a regular basis because dirt and debris enter along with the water. The use of a sump keeps the sediment at the bottom of the basin so water can flow freely. If no sump is installed, sediment could plug the basin and the pipe could require cleaning more often. The most common types of pipe used for storm sewer installation include concrete, corrugated metal, and high-density polyethylene. Area practice and project specifications will dictate the type of pipe to be installed. Concrete pipe may use bell and spigot joints similar to sanitary sewer, but corrugated metal pipe and high-density polyethylene are connected with manufactured couplers. A universal coupler is one type of connection used to join corrugated metal pipe. Dig around the existing pipe, allowing room for installing the coupler. Clean the pipe and center the coupler over the end. Lower the next length of pipe into place, spread the coupler apart, and butt the ends of the pipes together. Place a C-clamp against the bolt brackets and draw the brackets together. Insert the bolts with the thread ends pointing down. Hand tighten the nuts up to the bracket. Remove the C-clamp. Tighten the bolts evenly to hold the coupler and the pipe ends together as a unit. Do not over-tighten the bolts because the brackets will break off from the coupler. High-density polyethylene pipe is joined with a factory-formed coupler that uses nylon ties instead of bolts to hold the pipe sections together. Use extra caution when installing HDPE. Due to its flexibility, backfill material can cause shifting away from the desired line and grade. After a number of years, a storm drain pipe may need replacement or repair due to failure from ground pressure or root systems. Repairs to storm sewers are made with the same type of couplers that were required in the initial installation. When repairing concrete pipe, the damaged joint of pipe must be completely removed and replaced with an entirely new joint. Measure the diameter of the bell on the replacement pipe and divide in half. Mark the bell at the midpoint for the saw cut. Next, measure from the inside edge of the bell to the invert on the pipe. Using this measurement, mark the outside of the bell. Position the pipe for the cut. Put on the required personal protective equipment. Make depth cuts along the midpoint marks. Make the final cut following the mark on the outside of the bell. When sawing any type of pipe, pay attention to any material being discharged from the saw blade. Remove half the bell on the replacement pipe. Trim the cut. Follow the same steps for cutting the existing pipe. Take care not to damage the bell or spigot end of the existing pipe. Dig bell holes, clean and prepare the spigot ends of both pipes. Clean gaskets. Lubricate spigot and bell ends of the pipes, as with any normal joint installation. Lower the replacement pipe into the excavation with the remaining bell section on top. Slide the choker to the side of the pipe and lift to slowly rotate the bell to the bottom. While rotating, it may be necessary to adjust the choker several times to complete the rotation. Periodically check the bell for dirt and debris. After rotation is complete, move choker up by the bell and raise the repair pipe tight to the existing spigot. Tamp and compact dirt under the pipe to hold bell end tight to the spigot. Remove choker, use mortar to patch cut sections of pipe, and finish repair. Allow the concrete to harden thoroughly before backfilling. This maintains alignment and prevents leakage. Subdrains are designed to extract and control excessive groundwater. They are installed around buildings, along highways, and anywhere subsurface water may cause softening, frost heaves, or erosion. The subdrain system collects water using perforated pipe. The perforations allow groundwater to enter the pipe and follow the flow line into a controlled collection area, a storm drain system, or into the environment. Polyvinyl chloride, corrugated metal, and corrugated polyethylene are common types of pipe used for subdrain systems. PVC is often used in drain field applications. Standard joint lengths range from 12 to 20 feet. Two types of joints are available. Slip-on or push-on joints require grease for the installation. Solvent cement joints require a primer and glue. Install these joints using the same steps as bell and spigot pipe. Corrugated metal pipe comes in 15, 18, and 20-foot lengths. Joining this pipe is accomplished with the use of manufactured metal bands and bolts. PVC and CMP may contain only 2 rows of perforations. Each row is approximately 15 degrees on each side of the flow line. The perforations are installed down to accumulate water from the lowest possible elevation. PVC and CMP are rigid pipes that make the installation process easier. Corrugated polyethylene pipe is primarily used in and around buildings and highways. Common joint lengths for this pipe can range from 20-foot lengths to rolls of 100 feet or longer. Since the perforations are randomly located around the pipe, there are no specific installation procedures regarding the perforations. CPP is a flexible pipe and requires considerable attention during installation and backfilling procedures. A common design feature of installing perforated pipe uses a filter fabric and washed stone to envelop the walls of the excavation. When installing the filter and washed rock, the excavation must be dug deep enough to allow the fabric and bedding to be installed. These design features create a filtering system that prevents siltation and clogging of the perforations. The fabric is placed on the bottom of the excavation and up the side walls of the trench. The excess is secured on top of the bank. The washed rock is laid on the fabric and graded to the proper slope. The bedding is then installed to the design height above the pipe, and the fabric is blanketed over the bedding, enclosing the installation and creating a filtering envelope. PVC and CMP follow the same repair methods as sanitary sewer and storm drain systems, but pay attention to the location of the perforations. PVC can be repaired with a manufactured slip-on coupler or a flexible rubber coupler. CMP is repaired using the same type of manufactured couplers as used to originally install the pipe. CPP can be repaired by cutting the damaged section out with a sharp knife or handsaw. Cut a repair section to the correct length. Install the repair pipe with the manufactured couplers designed for this type of pipe. There are no formal testing procedures for perforated pipes. The real test of these systems is how well a foundation resists dampness, mildew, and flooding, and how well the subdrain maintains the groundwater at the proper level. For any gravity flow system, whether sanitary sewer, storm drain, or a subdrain system, always refer to local plumbing codes and job specifications. Following the proper procedures will ensure a long-lasting, efficient installation.